This is Mr. Beck Does Your Homework, Physics Homework number 23, question number 1. You're given this circuit, and it says find the equivalent resistance of the circuit shown in the figure. Well, when you're given a circuit, what you need to do is simplify it by taking parts that are entirely parallel or parts that are entirely series and replacing each of those with an equivalent resistance until you're left with a single resistor. That will give you the equivalent resistance of the circuit. So in this case, I have these three resistors that are entirely parallel, meaning any current coming along has a choice to go through one resistor, or the second resistor, or the third resistor, and then all of that current comes back together. So this section here is entirely parallel. So I can draw a circle around all of that and combine those three resistors as a single resistor. The way to do that is that in parallel, the total resistance 1 over the total resistance, or the equivalent resistance, is 1 over the first resistor, plus 1 over the second resistor, plus 1 over the third resistor. So the equivalent resistance of this 10, 5.5, and 6.5, I would have 1 over our total equals 1 over 10, plus 1 over 5.5, plus 1 over 6.5. And then once I've done this, I would have to do 1 over in order to get our total. What I do on my calculator is I use my inverse button. So I would do 10 x to the negative 1, you might have a 1 over x button, plus 5.5 to the negative 1, plus 6.5 to the negative 1 equals, that'll give me some small decimal, some small fraction. Then I'm going to want to inverse that number. So I do that to the negative 1, and I hit equals again. So my three resistors are going to combine to 2.295 ohms. So I'm going to get 2.295 ohms. I know you don't usually give you numbers there, but I'm going to give you that one. Now, since these three combine to 2.295 ohms, this circuit could be drawn again with a single resistor right there of 2.295 ohms. And then that second resistor, this 10 ohm resistor, is still there. So then that comes back to my battery and back around. So this is all three of these combined. This one is that 10 ohm resistor that was already there. And this is my battery that existed in the first place. So now I've got a circuit that's series. So this one and this one are in series with one another. So I can simply add them because in series my total resistance is going to be R1 plus R2. So my total resistance, or my equivalent resistance, for me is going to be 10 plus 2.295, and that will give me my total resistance, my equivalent resistance of the circuit. So I'm combining these three in parallel, replacing them with a single resistor. So this single resistor represents these three because they're all parallel to one another, and then I'm adding that 10 ohm to get an equivalent resistance of the whole circuit.